All right. Good afternoon, everyone, and thank you for being here. My name is Johnny Hooyberghs, and today I wanted to talk to you about my personal experiences with Azure Container Apps specifically. Just to be honest, I don't have any professional experience with Azure Kubernetes Service. I only have some personal experience with it, which means I've used it in the past for some of my personal projects to learn how it works and what it can do, but no professional experience. And then basically when Azure Container Apps became a new thing, I started looking into that, migrating my personal projects into Azure Container Apps. And it made me so happy that I'm today also using it for production and professional purposes. And this is the experience that I wanted to share with you. That's the reason why I call it Goodbye Azure Kubernetes Service and Hello Azure Container Apps, because for me personally, it was a goodbye for Kubernetes. This talk is not an anti-Kubernetes. Kubernetes is a very good thing. I'm very happy it still exists. But for my personal experience, I said goodbye. Very quickly, who am I? My name is Johnny, as I said. I'm from Belgium, so not very far away from here. Took the train, very happy. And I am a software engineer, I am a consultant, and our focus with the company is on the Microsoft stack. So we do .NET development, backend, frontend, and we also do Azure Cloud, very specifically Azure. I'm a Microsoft MVP, and basically everything that I'm telling you today is already available on my GitHub page. So I have a GitHub page with my nickname, Johnny. There's a QR code and there's a link in the bottom of every slide where you can directly navigate to my GitHub page. So yeah, the slides are up there, all the examples are up there. So basically you can already walk outside. You have everything that you need. But again, very happy that you decided to come here to listen to me. So before diving into container apps, I'm just going to very quickly talk to you about why we need containers and why we are using containers today. Well, basically, the idea for containers comes from the shipping containers, obviously. If we go back like 100 years or even a little bit more, shipping things was quite hard because things come in different sizes. We have boxes, we have bags, we have barrels, we have all kinds of stuff that we put in containers, and those containers were different sizes, which means we needed a lot of manpower to basically put all of those things on ships. They didn't fit the correct way. It was hard to transport, and basically we revolutionized the way we ship things by putting them in containers. Because if you put them in a container, and a container has a very specific size, and it can actually be moved around a lot easier. In this example, we know containers, they look like this. They go on ships, they go on trains, they go on lorries. They have a standard size. And the people who are moving these containers, they don't care what's inside of the containers. Of course, the police cares what's inside of it, if it's cocaine. But you shouldn't really care about what is inside of the container in order to move it. And that's the exact same way of thinking we are going to do in software development. Because you as a developer, you create an application, but the guy from operations that needs to install the software somewhere, he doesn't really need to know about the software. He just needs to know how to deploy it. And how to deploy it, if we work with containers, can be standardized in a standardized way. So you can deploy it in the cloud or on-premise, doesn't matter. Just like when you put a container on a ship or a lorry, you don't really care. It should just work. So inside of the container is basically your software, but also your configuration and your dependencies. All of that combined makes sure that your application, when it's deployed somewhere, will just work. And this is, of course, a very great idea. And that is why today, even in cloud environments, we are using containers so many times. All right. So now that we know what containers are, by the way, this is mostly how I do my containers when I'm doing personal projects instead of this like enterprise grade stuff. So just wanted to let you know. Also, the examples that I will show you today will look a little bit more like this. But of course, that's because I only have 1 hour of time. All right. If we look at Azure specifically, the Azure Cloud, there's a lot of services we can already use today that have support for containers in one way or another. From the left-hand side to the right-hand side, on the left-hand side, we have the web application, just your service app or your web app. You can deploy that, but you can also deploy that as a container. So you can containerize your application, and that can run in whatever technology. Doesn't need to be .NET or can be whatever you want, basically. That's the concept of a container. And you can deploy that to your web app, and that will also work. But that's just running one container in one web app that has a web UI, for example, or a web API. Next, we have the function app, the serverless offering for function apps in Azure. This also has support for containers. You can put your function app inside of a container and deploy the container to a function app in Azure. So again, the services we all know and we all use, they already have support for containers. Then, of course, when using containers, you want to do some orchestration. You want to have multiple containers working together. You maybe have a distributed application or a microservices application that consists out of multiple of these containers, and they need to work together. Well, the first step Microsoft did was doing the container instance, which is still only running one container in one container instance service. But then we also now have container apps. And container apps is a little bit like container instance, but you have multiple containers that can run within a single container app, and you can have multiple container apps working together to build your distributed application. And then, of course, on the right-hand side, we have Azure Kubernetes Service, where Kubernetes is your orchestrator. It will orchestrate all of your containers. They will work together, and this is also available in Azure. And actually, Azure Container Services was first. Microsoft implemented a managed version of Azure of Kubernetes, with the Azure Kubernetes Service. But then they basically saw that developers don't want to care about all of the infrastructure that is needed to work with Kubernetes. So they basically built an abstraction layer on top of Kubernetes, and that is called Azure Container Apps, to make it easier for us developers to work with the complexities of container orchestration. So again, this talk is not like a Kubernetes versus container apps. This is just like container apps is an option. It works in a very similar way to Azure Kubernetes Service. Unfortunately, the namings are a little bit different sometimes, so I will explain the differences. But Kubernetes can still be a very valid option for you if you really want to have the full flexibility on how you do your container landscape and which open source tools you want to use in combination with that. So again, Kubernetes is still a viable option, but also container apps. So what is container apps? Of course, it is there for you to deploy your distributed or microservices application. So if your application exists out of multiple components that need to work together, container apps can really be a solution for you. It is serverless if needed, which means that, for example, in Kubernetes, you need to specify the virtual machine nodes that are available for you to run your containers on. That is not serverless, because you need to specify before you run any containers what your nodes are and what the size of your nodes is and how many nodes you have. In container apps, you can go fully serverless, which means that Microsoft Azure will do that for you. It will basically scale your applications for you, and you don't need to worry about how many nodes you need to actually make that work. And it says if needed, and I will show you in a demo later, you can still specify the nodes if you really need to in Azure Container Apps, but by default, you don't have to. So you have both options. Of course, it's a very good service to run your cloud-native apps because you put them in containers and they will just work. And it's also built on top of open source software components. So all of the software that lives inside of that abstraction layer that is Azure Container Apps is built on open source software components. And I have listed a couple of them in the bottom. For example, it is built on top of Kubernetes. So Azure Container Apps is just Kubernetes. It's just that layer of abstraction on top of Kubernetes. It uses KEDA, which is an open source tool. KEDA stands for Kubernetes Event-Driven Autoscaling. So it It gives you the opportunity to auto-scale your application based on the Keda open source software tool that helps you with that. It also has support by default for Dapr. Dapr is the distributed application runtime, and I will talk about that in the end of my presentation, which can basically help you to more easily make your applications talk to each other or your application components talk to each other. And then finally, using Envoy for your service discovery, ingress, and stuff like that. So these components in Kubernetes, you can basically choose them. In Kubernetes, if you want to use something different, you can. In container apps, you're basically stuck with these because they are used by the Microsoft teams to build Azure Container App as that layer of abstraction. So you're stuck with them, but they are open source. So with that, you can actually find a lot of documentation, find a lot of help, and find a lot of components with that that will make your applications work. As I already told you, it scales dynamically, and it can even scale to 0. So if you're going completely serverless and you don't specify your nodes, you can scale your application to 0 if needed. Which means that if there's no usage, if there's no HTTP requests, for example, you can completely scale down to 0 and you don't pay anything, which is nice. If you, of course, in Kubernetes select an amount of nodes, you pay for the virtual machines that run your nodes. And you will pay for them always, even if you don't have any resource usage. For Azure Container Apps, this is different, which is cool. So what can you build on Azure Container Apps? Makes sense. Your distributed and microservices application, as I told you, you have multiple containers working together. They can talk HTTP to each other, but also just web applications, because Azure Container Apps has ingress availability by default, so you can just enable it, and now you can reach your application from the outside world, so you can create a web application for your users. You can also do event-driven processing applications. You can make your container apps work together with other Azure services, like Service Bus, for example. You can do messaging processing from Service Bus, works perfectly fine, and of course, background processing applications will also work. I'm not going to explain what Kubernetes looks like. This is just a diagram of what a Kubernetes cluster can look like. And the reason I'm showing you here is because I want to talk to you about the differences between Kubernetes and Azure Container Apps. So if I look at it very high level, a Kubernetes cluster exists out of multiple nodes. So a node is a virtual machine that can run your applications. That is your Kubernetes cluster existing out of multiple nodes. These nodes are called worker nodes. And these worker nodes, they contain your containers, but not directly your containers. They contain pods. It's what they call it, a pod. And inside of your pod lives your application within a container. You can scale your application by creating multiple replicas of this pod within a specific node or spread among multiple of these nodes. So you have Kubernetes cluster, you have nodes, you have your pods, which can be replicated, which can be dynamically scaled, running your containers. Now, in the container app, we have kind of the same architecture. On the outside, here in green, is the container app environment. So your environment in container apps is actually a little bit like your Kubernetes namespace. So your Kubernetes cluster can have multiple namespaces to basically make sure that one application cannot touch the other application. So you can have multiple applications within the same Kubernetes cluster. You can do the same thing in container apps by creating a container app environment. And your container app environment is basically a virtual network. Everything that you put inside of your container app environment can talk to each other on the private virtual network, but they can't communicate with, or the outside world cannot communicate with them. Inside of your environment, you can create one or more container apps, one or multiple container apps. Again, when you deploy multiple of these container apps within the same environment, those container apps live in the same virtual network and they can talk to each other, which is nice, which is, of course, what you want for a distributed application or a microservices application. Then inside of your container app, you can build multiple revisions. This is something that I don't really know if that exists in Kubernetes. But I will show you in a demo, and it becomes very clear what a revision is. Basically, when you deploy a first version, that is your first revision. And if you want to deploy a newer version, it creates a new revision for you, and it keeps all the older revisions deactivated for you. So if you make an oopsie and you deploy something that doesn't really work, you can very quickly and easily go back to a previous revision that is still available in Azure, so you can basically fix that. So it will keep your older revisions. And then within your revisions, we have the replicas we know from Kubernetes. So you can scale your application horizontally by having multiple replicas of the same container image. And these will also live in that revision. So this is the architecture for container apps. So let's stop boring you with some slides and just show you some Azure stuff. If you want to create a new container app, is this readable for everyone in the back? Yes, and maybe. Let me try to make it a little bit bigger, just to be sure. Maybe that's going to be a little bit too big, we'll see. So when you create a container app, you search in the marketplace for container app, obviously. So if this is your first container app within your subscription, you're also going to need to create the environment, the container app environment. I already have an environment, so I'm just going to reuse that one. But again, just remember that this is one container app, and you can create multiple of these container app services within the same environment for those to be able to talk to each other. But if you want to have a completely separate application from this one, you can create a second or a third and so on environment, and then they will be completely separate. Of course, you give your container app a name, for example, example 01 API. Let's say this is an API. And you put that in a region, and within that region, you will find a list of all your already created container app environments. So I have a CAE, which stands for Container App Environment for NDC London. In the next step, you specify your container. So your containers will come from a container registry. That can be a public registry or a private registry. In my case, I've pushed my container images on a private container registry from Azure itself, so an Azure Container Registry with the name ndclondon.azurecr.io. And this one has all of my examples. So I'm going to use the example 1 API container image, the latest version. And here you can select a workload profile. As I told you before, you have the option to do serverless or dedicated workload profiles. And this is actually the nodes that I was talking about in Kubernetes. So I'm going to use consumption, which is the serverless offering, which means I don't really care how many nodes that I have. I'm just going to put this container app in the consumption, which means that I can use for one single container app up to 4 virtual CPUs and 8 gigabytes of memory. And you can specify in different steps how much resources this specific container app can use. So I'm just going to use the minimum one, so a quarter of a CPU and half a gigabyte of memory. In my container app, this is an API. It's an API that just returns a message to me. And this message has what I call a version, and that version is configurable by using environment variables. So the environment variable version can, for example, be NDC. In the next step, you can enable or disable ingress. Ingress means, can I talk via HTTP to this container, yes or no? And when you enable this, if it's a web application, for example, you still have 2 options or 3 options even. You can limit it to the container app environment, which means that all the other containers within the same environment can talk to this container app, or you can open it up to traffic from everywhere. If you want to have a public-facing website, this will create that reverse proxy for you. Of course, you can do HTTP or TCP. I'm just going to ignore everything, and I'm going to put the target port. So my application, my container application, is listening on port 8080. By the way, if you don't know, since .NET version 8, by default, your container port is 8080. Before version 8 of .NET, the default was port 80. So this is something that actually took me a while to figure out. And I think that's all we need. This shouldn't take too long, and if it takes longer than 30 seconds, I will just show you the one that I already created beforehand. Let's go. So I have this one also. So if it's created, you basically see your Container App service. And here are three interesting things: revisions, containers, and scale and replicas. Let's first go to scale and replicas. This is a web application that I've just deployed. So Azure Container Apps will see that I've deployed a web application with an ingress configured. So it will automatically put my scale rule setting to 0 to 10, which means a minimum of 0, a maximum of 10 replicas. So horizontally scaling my application. And by default, it's using the HTTP scaler. And the HTTP scaler is part of that KEDA open source tool, that Kubernetes event-driven autoscaler platform. And you can actually scale on different things. By default, it's going to do HTTP, which means if there are more than 10 concurrent requests at a certain amount, at a certain given time, it will actually scale up automatically. It will add a new replica. And then if it has 10 concurrent requests for all the replicas, it will go to a third replica, and so on, until it reaches the maximum that I said to be 10. If there is no request for some time, it will scale down to 0. It will basically kill your running application until the first request comes in. It hits your reverse proxy. Your reverse proxy will basically wake up the autoscaler. The autoscaler will add one more, will add the first new replica, and then it will handle your request. There's also scalers for CPU, memory. There's scalers for all the things we know in Azure. You can do, for example, scaling based on messages on a queue. So if there's a lot of messages on your queue, you can automatically scale up to basically process all of those messages in parallel. And you can create your own custom scalers. So you can have your own custom scaler added as a component in KEDA, and you can then use that here as your scale rule. If you want to change your scaling, you basically need to create a new revision. So you can do edit and deploy, and you can change a couple of things. You can change the container itself with all of the values that we've seen before. Where does the container come from? What is the version of your container image? What is the CPU cores and memory that you want to use for this specific container app? And what are the environment variables? You can also change the scaling rules, of course, here. So it's just dragging these around. And by the way, I'm showing you all of this in the portal. Of course, you're not going to do this in the portal when you're doing professional development. You're going to use the tools like ARM templates or Bicep to basically do this automated in your CI/CD pipelines. But I just wanted to show you in the portal to give you a little bit more context. You basically drag these sliders around, and you can say, I have a minimum of 0 and a maximum of 300 replicas. You can never go above 300 here. And if you do create, it will actually create a new revision for you. So if I go to revisions, you can now see that I have my old revision still running, and I have my new revision that I've just created that has here the total number of replicas currently activated, and this one is still activating. So your application will not go down. It will basically spin up your new replica, and then when your new replica is ready to receive traffic, it will shut down the old revision. So if I refresh this, they should now be switched. So you can see that now my new revision is running and my old revision is deprovisioning. So it's basically getting put to the side. And you can also see that the traffic is 100% here and 0% here. So this is your scaling. This is basically your reverse proxy that says all that traffic needs to be forwarded to that specific revision. When your application is scaling, you can see the total replicas going up here. So if you create an application that gets a lot of HTTP requests, you will see this number going up, of course, following the rules that you specified. In my case, from 0 to 300. Now, if I want to show you how multiple of these container apps are working together, I'm just very quickly going to show you some code just to show you or give you an idea of what simple example that I'm actually using here. So I've created the API, which is the one that I've deployed just now. And this only has one endpoint called status. So this just says hello from version on an environment.machine name in a specific time. So this is a very simple API. And I didn't actually show you, but if I go to my newly deployed application 01, which is not here, refresh, here it is. Because I enabled ingress and I enabled it to be available from the outside world, I have an application URL. And if you click that application URL, and you have some patience, it seems, a lot of patience. All right. Then I have a status endpoint. And this will give me hello from version NDC, which is the environment variable that I've set on example 01-API-random numbers. So the random numbers are basically identifying your revision and identifying your specific replica. So I only have one replica available because I'm not scaling, or at least it's not necessary to scale. So it will always get the same one back. So that is what the API does. Now, if I go back to my code, I also have a worker application. So a worker service, which is a background service, which has a background worker class. This runs continuously and actually calls using the HTTP client, my API. And the cool thing with Envoy is that you have automatic service discovery. So in order to talk via HTTP to your other container apps, the only thing you need is the name of the container app. So if I deploy this application, and I'm not going to do it, I'm just going to take the existing one, this worker. If you click on your containers and then your environment variables, here, the status endpoint environment variable is the one that I'm using to do my HTTP call. So this is my address that I'm actually calling, and the value for this address is http://example1-API/status. So the DNS name, just like your services in Kubernetes, is just the name of the service. In this case, the name of the container app. But this also works for scaling. So if I have multiple replicas running for example1-API, it will actually hit my scaler and it will get assigned one of the replicas automatically. I don't need to worry about that. It will just work out of the box. But of course, you need to do that configuration. You need to know in your code what the name of your microservice or whatever is in order to be able to call it. Now, if you look at the log stream, so the log stream is a live stream of your console log for your application. You can actually see that every second it is actually getting hello from version alpha. This is the one that I deployed earlier. So this is not the NDC one message every second within that worker. So it's actually working. Now, if you start to scale your application, you can actually do that manually or again with the tools that you know from code or from infrastructure as code. So let's go to the API. You can, of course, just fix your number of replicas. If you do edit and then scale, you can put these sliders wherever you want. So I can go 12 minimum, 12 maximum, which means always 12, never less, never more. This is a bit fiddly, the UI, So let's say it's 12.12. Now, if you do this with the same running application, which is the one that I've prepared beforehand, example 2, and you look at the worker. So example 2 uses 2 different replicas. You will see 2 different replicas. So if you look very carefully, you can actually see here the name of the replica, X5 5W. So these are my 2 replicas, and it's going to switch randomly between those 2. It's not a round-robin mechanism, it's just a random mechanism, which makes sure that if you have 2 replicas, 50% of your traffic will hit the first, 50% of your traffic will hit the second. So that's the idea. And again, just works out of the box. The only thing you need to do is change your scaling settings, and you don't really need to worry about URLs. Your service discovery will just work out of the box. And things become interesting when you look at replicas. Revisions. So with revisions, I told you, if you create a new revision, all the old revisions, they will be kept for when you do a mistake. You can easily go back to a previous revision, but you can also change your revision mode into multiple revision mode. And if you do that, you basically change your container app to be able to run multiple revisions at the same time. And this is very nice if you want to do A/B testing, for example. You can deploy the new version of your application under a new revision, but keep the old revision active and just split your traffic. So if you do this, and you basically create a new revision based on an older revision, let's do that. And if you wait a little bit of time, you will get 2 of these active revisions running simultaneously, and you can change these traffic numbers. So you can actually change it, for example, to 80% of the traffic needs to go to my old version and 20% needs to go to my newer version. And if something goes wrong, only 20% of your requests gets hit by that problem, and hopefully not too many of your users will notice. And then you can fix your problems beforehand, and then you can try again. And if everything looks to be working, you can increase 20 to 30 to 40 to 50%. And if everything seems fine, you can just switch over 100% the new revision, 0% the old revision. Again, I'm doing this all in the UI right now. You can do this from your pipelines automatically, obviously, with all of the tools you know. So in this case, I can't change it. I'm not sure why. So I'm going to go to my 3rd example, because this one should work. This one has 20% for one and 80% for the other. So you can just change those numbers to whatever you want, of course, between 0 and 100. But that's the idea. You can have 3, 4, 5, 6 revisions running at the same time, whatever you want. Again, to me, this looks like a more managed way of doing these kinds of applications, of doing these kinds of things. In Kubernetes, these things will also work, but you need to do a lot of manual work to make that actually work. Here, it works out of the box, thanks to the concepts of revisions and replicas. All right, back to the slides. If I can find them. I closed them. How do you present? F5, thank you. Perfect. All right, so before I go a little bit deeper into what else you can do with container apps, I'm going to talk about 2 things. That's .NET Aspire, which is quite new since November last year. I'm very quickly going to discuss what it is and how you can use that in conjunction with container apps. And I'm also going to talk about Dapr, because Dapr is an integral part of container apps. I will show you a couple of examples on why you can use Dapr, but you don't have to use Dapr. It's the same for Aspire. So Aspire is a new tool from Microsoft that looks a little bit like Dapr, and it's basically your distributed application orchestrator. So you have multiple running services that need to work together in your distributed application or microservices application, and you're going to compose your entire application out of these components, so it's for your app composition, basically. You also have the service discovery, where I was talking about, and you have support for components for commonly used services. So the idea of Aspire is that you as a developer don't need to worry about the whole landscape for your distributed application. You have your own services that need to talk to each other, but you don't want to care about how do they need to talk to each other. What is the URI? How do I need to secure that URI? But also when you talk to external components, you don't want to manage those external components when you're developing locally. You just want that to work out of the box. So Microsoft tries to make that whole development workflow easier for you, the developer, by using these tools, for example, .NET Aspire. So what happens with .NET Aspire, if you do File New Project in Visual Studio, you can actually find the Aspire template, and that will create a demo application for you to show you what the power of Aspire is. And what it creates is something similar than the example that I did. It creates an API service in the top and a website, a web application in the bottom. And the web application will call the API service. The API service is very simple, and it's the example that you probably all know about. It's the one with the weather forecast. So it's an API which gets a bunch of random weather forecasts, very simple. And then because Microsoft is trying to push Blazor, of course, a Blazor application where your weather page will basically call this API, weather API, and get the weather asynchronously. Now, with Aspire, it creates an additional project called the application host, and it puts this project as a startup application. And this is for people who are hardcore C# developers and don't care about infrastructure, don't care about cloud. They just want to do C# stuff. Because the app host will basically tie all of these things together. If you look at the program.cs class, it tells you, I'm going to build a distributed application with the distributed application builder. Maybe I need to use this. So distributed application.createBuilder. We know about the web application builder and the host application builder. Now we have also the distributed application builder. Now, with this builder, I can build the whole landscape of my distributed application. For example, I am going to need a Redis cache. I'm going to do some caching, and I'm going to use Redis for this cache. And the only thing I need to do is put the extension method at Redis container with the name cache. And basically, Aspire will download a Redis container image to your system locally, and it will also run it in your local Docker environment so that you can actually use it from your application without the need for you installing it manually. Then you're going to define your own services for the ones that you are basically writing yourself. So we have the API service, which comes from your projects because it's in your Solution Explorer with this name. And then you're going to add a second project, which is the web application, which is called Web Frontend. And it's going to have a reference to the cache because it's going to use the cache. And it's also having a reference to the API service because it's using the API service. So with this little file, you basically wrote in C# what your landscape looks like. I have 3 services, my web API, my web application, and my Redis cache. The web API and the web application I wrote myself. They are part of this solution. And then the Redis is an external dependency, basically, that I'm going to use. And if I just press play, and I open my Docker, you can actually see in my running containers, automatically getting me the Redis latest image. So this image is now a running container on my local system, and it will just work. And if I look what happened when I started my host application, I now have an Aspire dashboard. So I have a dashboard that shows me my whole application landscape, which runs my API service with a link to that endpoint. This is my weather forecast. If I refresh, I get the random weather forecasts. It's a little bit like the weather in Belgium and probably here also. And then I have my second link to my web frontend, which is my Blazor application that gets the same weather. But if I refresh this page, I get the same weather all over again instead of the random weather because there is the Redis cache in between. And the Redis cache is not one of my projects. It's actually a running container, which is this one. And the cool thing about the Aspire dashboard is that you can also look at your logs from this one single dashboard. I can click project, and I can see my console logs for my API service. I can see my console logs for my web frontend, and I can see my console logs for my containers that are also running as part of my application. Again, this will help you as a developer to run your distributed or microservices application locally with all of those dependencies that you have by just pressing play in Visual Studio, and it should work. I don't work for Microsoft. It should work. Now, if you want to deploy this to Azure Container Apps, they made it very simple. So you have a command line tool called AZD, the Azure Developer CLI, not the Azure CLI, but the Azure Developer CLI. And it has a couple of things you can use. For example, if you create your Aspire application just in the way that I did, you can do AZD init to initialize your application to be able to be deployed to Azure. And if you do AZD init, it will ask you some questions. It will look at your code and it will tell you, oh, this looks like an Aspire application. Which projects do you want to include in this deployment? And then you can specify, okay, I want my API service, I want my web frontend. You just check them. It will ask you a couple of more questions, like what do you want your resource group in Azure to be named? And it will create all of the bicep files for you. And then when you do AZD up or AZD deploy, it will basically deploy all of that to your subscription. So it will then ask you to authenticate towards your Azure subscription, and then it will start running all of those bicep scripts to actually deploy that application. And that's exactly what I did. So if you look at, it created a separate resource group, this one. There we go. It actually deployed a container environment, and within that container environment, the API service, in the bottom, the web frontend, and then the cache also. So the cache is not the application that I wrote, it's just getting the Redis image, container image from the public repository, and just also putting that into my whole container app environment. So now my application also runs in the cloud, just like it runs locally. And I didn't really need to do any work for that. Everything happens automatically for me. So I think this is cool for your smaller applications and for your developer experience. You can, of course, combine that with writing your own pipelines and doing like the deployment to the cloud thing. You can fully customize, but still use Aspire to run things locally very easily without the need to link to existing environments, for example. Just run everything locally, which I think is pretty cool. This is still in preview, of course. The team at Microsoft is still working on this. It's going to get better and better over time, and additional components will be added to it. So right now I'm using Redis. There's also support for SQL Server. There's support for Postgres and other tools. And this list of this market or this marketplace of components that you can use together with Aspire will, of course, grow over time. And I hope that maybe some of you will also work with that and will create new components for the community to use. Now, back to my slides. Next to Aspire, something very similar is called Dapr. Who has never heard about Dapr? Everyone has heard about Dapr. Okay, so Dapr is a part of Container Apps. You don't have to use it, but you can use it. It is available for you. So basically, Dapr is the distributed application runtime. And again, you can use that for your microservices or distributed applications. The cool thing about Dapr is it allows you to create a distributed application where every component or every service is written in their own technology or language or whatever. That's, of course, something that always works with containers. But sometimes when you want one technology to talk to another technology, you can, of course, use HTTP because that is supported everywhere. But if you use something very specific, things become harder. How is service A going to talk to service B if they don't know the same protocol? Well, Dapr can help you with that because Dapr is going to try and abstract away the cloud infrastructure So how do I talk from one service to the other? And also the configuration. Where is my other service located? What is the connection string? What is the secret? Whatever that I need to be able to talk to another service. So that you as a developer can focus on your application code and not so much on configuration. And of course, this also enables application portability, because if you have one component and you want to switch it out for another component, which is the old saying, like if you're a developer, you need to make abstractions everywhere because someday you want to switch out your database for something else. That's also the thing that Dapr tries to do, and how it does that is very cool. So when you run a container within a Kubernetes pod or within an Azure Container App, you can actually put containers next to it within the same container app or within the same pod. And these containers are called sidecar containers. So it's like a helper container to your application container. And this is exactly what Dapr does. So Dapr will deploy for you a sidecar. And when you do service-to-service communication between your services, you're not going to directly talk from your service to the other service. You're going to ask Dapr, Dapr, could you please call my other service? And then Dapr will call from its sidecar to your other application's sidecar. They will communicate to each other with resiliency, and I will show you an example in just a moment. And then that sidecar will talk to your service. And this is what I was talking about. When you have, let's say, the service A on the left-hand side is written in Java with some very obscure protocol, and then service B on the right-hand side is written in .NET with another obscure protocol. They can't talk to each other, but they can talk to the sidecar. The sidecars can talk to each other, and this way your applications can talk to each other. You don't need to worry about configuration because you have the concept of components in Dapr. Dapr has a whole list, a whole marketplace of components, and Dapr can talk to an HTTP service, a gRPC service, a WCF service. It can talk to external services like a Redis cache or a SQL database, stuff like that. So as you can see, you can also communicate with those external services or components by following that arrow straight up. Now, what kind of Dapr components are out there? Well, you have the input-output bindings, which is basically communication into your service or out your service, like HTTP communication, gRPC communication. There are multiple of these bindings available. There is support for state stores, where you want to store your state in a SQL database, in a document database, in a cache, a Redis cache, for example. These are your state stores. Your secret stores. Dapr has support for Azure Key Vault, for example, to store your secrets. So you don't need to worry about the connection strings from your application. You just ask Dapr, I want this secret, and Dapr will fetch it for you depending on which components you activated. Configuration stores to get your configuration, pub/sub to do your service bus messaging or whatever. Middlewares if you want to work with your request pipeline, for example. You want to work with the requests that come in. You want to make some changes there. There's also support for that. Let's show you a little demo. So I've created an application, the Dapr example. So the only thing you need to do as a developer, instead of calling from your service to another service, or talking to an external service, if you're using Dapr, you just need to install the Dapr client. And with the Dapr client, you can do some fun things. So if you look at the worker, the one that is calling my API, and you look at the configuration, you need to add, this is the wrong one, sorry. This one, you need to add the Dapr client to your dependency injection. So services.add_Dapr client will basically allow you to inject the Dapr client into your classes where you need them. And the Dapr client can do everything for you. So if you want to talk to your state store, the Dapr client can do that for you. If you want to talk to another service, the Dapr client can do that for you. So everything becomes the Dapr client. So that will be your abstraction in code. And in your code, you don't need to worry about configuration or technologies or communication protocols. You just use Dapr. And inside of your worker, instead of using the HTTP client, you're going to use the Dapr client, the one that you just configured in dependency injection. And there's different kinds of methods that you can call to talk to states or state stores, or to talk to configuration or secret stores, or to invoke a method over an HTTP connection. So in this case, I'm doing invoke method, which is going to be a get method. And you just specify the name of your, or the ID of your application. So when you have multiple containers running in a container environment, you can enable Dapr on those containers, and you need to specify an app ID for all of your container apps. And this app ID is the only thing you need to be able to talk to these services. So this, for example, example 6-API is the Dapr application ID for my API, and I'm going to call the status endpoint. And this call will do the HTTP call for me. The cool thing about this is that this also has resiliency built in. So if this call fails for some reason, you can configure, okay, if it fails with a 500 exception, just try again. Try again, try again, try again for a maximum of 100 times, do an incremental backoff. All of that thing can be configured within Dapr and not within your code. So the sidecars will take care of all of that hard stuff. You as a developer focus on your code and not the technology to talk to another service. By the way, my API that I've deployed also uses the Dapr client, and it actually uses the Dapr client to use a Redis cache. So I've created a Redis cache on Azure. So whenever I call the API, instead of generating a new message, it's first going to check on the Dapr client if there is a state available in a component in Dapr called Redis with the key message. And if it's available, it will return this. If it's not available, it will create a new message and store it in that state store. How do you deploy this? In the same way as you in the same way you deployed the other applications. So let's go back to my NDC London resource group. Then it should be example 6. And the only thing you need to do extra is click on the Dapr and enable Dapr for this container app. So you deploy your container image to this container app, and when you enable Dapr, it will install the Dapr sidecar next to your container automatically. So again, you don't need to do that. You need to specify your app ID, which is example 6-API. So this will also be your service discovery when you want to do a call. You need to specify your application port. So for my application, I am listening to 8080. So my Dapr sidecar now knows that if it needs to communicate with my application, port 8080 is the one to call. You can specify the protocol, HTTP or gRPC, and you can add some API logging so that the sidecar will also show you what is actually happening. And if you look at the log stream, for example, you have your container that is running and listening, but you also have the Dapr sidecar container listening. If you want to work with these Dapr components, so if you click Dapr, in the bottom, you can actually see a list of all the components in Dapr that you are using. So this API is using the Redis component. So if you want to manage that, you can actually go to your container environment and you can add Dapr components. And you can do Azure components or generic components. So Azure components are very specific to Azure. So Azure has a couple of these components created for you. Do you want to communicate with Azure Redis? That's what I did. Do you want to communicate with Azure Secrets, Azure Key Vault? You can add it here. And now your Dapr is available to talk to your Key Vault. So again, you basically shift these things out from your code, but of course you need to do them somewhere. So in this case, you need to configure it here. Again, you can configure it in the portal, but you can also configure it in your pipelines as part of your infrastructure as code, and that will also work perfectly fine. I have 5 minutes left, so there's one more thing that I want to show you in example 7, which is your resiliency. It's also a part of Dapr. So in this case, you don't really need to use the Dapr client. You can just, if you look at my second Dapr example, my worker does the exact same thing. It's using the HTTP client to talk to my API. So it's not using Dapr. I'm not using the Dapr client. And I made one little change to my API. I basically, in 50% of the time, I'm just going to throw an exception. So my API call will fail 50% of the time. Now, if you deploy this to Azure Container Apps and you enable resiliency, you can enable resiliency, in this case, for example, for HTTP retries, which means if you get a 500 something, you can retry for a maximum of 100 times with an initial delay of 100 milliseconds. It will do an incremental backoff, but no more than 1 second. And if you save this, again, out of the box, this will just work. If you go to your URL and you call your status endpoint, it will always work. You can keep refreshing this. You will never see the exception because the Dapr sidecar that calls the API will basically retry that for you if that fails for a maximum of 100 times, of course. If you play around with these numbers, like if I put instead of 100 milliseconds, like 5 seconds, you can actually see that happening because when you refresh and it immediately refreshes, you know that it worked. If it waits for 5 seconds, you know that it failed. It's waiting for 5 seconds to retry. So again, this works out of the box. You don't need to add anything to your code. This is part of Azure Container Apps. And then finally, because this was basically all that I wanted to talk about, many years ago, it's almost 10 years ago, I've created an application while I was still teaching people to write programs in C#. It was a very basic C# course. And I was bored of always writing console applications with my students. So I created a little game. And this game, the students could use to learn to write C# code. And the C# code would actually make a robot do some fighting, like a visualized battle. And this is the thing that I actually deployed into Kubernetes at first, which worked perfectly fine, but then in container apps. And the cool thing about container apps was I deployed it. It just worked. I didn't really have to do anything. So this is called C# Wars. This is actually 4 container apps within the same container environment. And maybe I'll need to show it first. So if I go to web.csharpwars.com, you can actually play this by creating a new robot, a virtual robot, giving it some health and stamina, and then writing some C# to do something. So these are templates that you can choose from a dropdown to make it very easily to show you. But my students should write this code themselves. So this is how to learn how an if works, how you declare variables. And when they run this, they can actually immediately see a result instead of a boring console application. So that was the idea. Please go away. So if you view the battle arena, it will show you a 3D representation of all these robots fighting on here. So this is publicly available. You can play around if you want. Every once in a while, I just remove all the robots because for some reason people always use profanity in their namings. But whatever. But I deployed this to Azure Container Apps because I made it into an Orleans cluster. I don't know if you know Orleans. Orleans is the Microsoft thing for creating actor-based applications, so based on the actor model. And this is pretty cool because basically everything that happens, all the logic in the backend, like for the robots, for what the robots do, for the arena, everything is an actor and all these actors work together. And the cool thing about actors is they can be easily scaled because each little thing in your application is a single actor, and a single actor can be, all of your actors can be sharded over multiple nodes. And this is exactly what you have with container apps. So if you look at these 4 container apps, you basically have the web API, which is just the web API that Unity uses to call. It's a website, the website that you just saw, and then 2 Orleans host applications. The Orleans host application hosts your actors. And Orleans has a dashboard, so I can do orleans.csharpwars.com. which basically shows you all of your different actors. So I have 14 actors running somewhere. They're processing now 15. They're processing something. I think some people are actually deploying robots now. But if you click silos, which is a concept of Orleans, each silo that can host actors is actually a running replica in an Azure Container App. So I showed you I have 2 Orleans apps, which is actually a host and a vhost. The vhost is just purely validation. The regular host does all the processing. And I can easily scale this. I can scale this to how many I need in order to make my application run stable. And Orleans just supported out of the box because Orleans also does service discovery. It sees all of the replicas and it knows where to activate all of the actors. So yeah, in Kubernetes, I needed to do a lot of configuration to make this work, but in Azure Container Apps, I deployed and it just worked, which I thought was pretty amazing. And with that, I'm out of time. So if there's any questions, I will remain here for some time. Otherwise, thank you so much and enjoy the rest of your day.